We, Bachelor of Computer Science student from University Technology Maratapa Perak branch, will be presenting about system performance and optimization in operating system in this video. Assalamualaikum and salam sejahtera. My name is IMRAN bin NORHIDZAM. I will be first to showcasing the content about in this video topic. The first one is identifying bottlenecks performance, the second developing optimization strategy, and the third one impacts of resources management techniques. Improving system performance is a critical endeavor for enhancing user experience, operational efficiency, and overall productivity in today's technology-driven environments. As technology evolves, the demand for faster and more reliable systems intensifies, making the identification and mitigation of performance bottlenecks a continual challenge. Common bottlenecks include CPU, memory, disk input-output, and network limitation, each capable of significantly slowing down system operation. Performance bottlenecks in an operating system can greatly reduce efficiency, causing slow response times and decreased productivity. Secondly, the identifying and addressing these bottlenecks is essential for improving system performance. Last but not least, by understanding where bottlenecks occur and employing effective resource management techniques, we can optimize performance for a more responsive, efficient, and scalable operating environment. High CPU usage, often caused by inefficient processes or purely optimized application, can lead to sluggish performance as resources are monopolized. Memory bottlenecks arise from insufficiency, RAM or RAM or memory leaks, causing excessive paging and degraded performance over time. The disk of input-output bottlenecks manifests through slow read, write, speed, or high input-output operation is exacerbated by fragmented files or outdated hardware. Network bottlenecks, characterized by limited bandwidth or high latency, affect network-dependent application and can be worsened by congestion or inefficiency configuration. Addressing this issue requires targeted strategies tailored to specified bottlenecks. For instance, in cases of high speed usage on Windows 10 due to background process like Windows updates or Cortana, optimizing resource allocation by disabling unnecessary services and identifying and terminating CPU intensive tasks using tools like Task Manager can significantly improve responsiveness. Next is in server environment. Running Linux memory management issues such as memory leaks in web server application can gradually degrade performance. Regular monitoring of memory usage and proactive optimization of application code to fix memory leaks represent effective strategies in such scenarios. Root causes of performance bottlenecks often from the hardware limitation where outdated or inadequate hardware struggles to meet modern computational demands. Software inefficiency including purely optimized code or inefficient resource management further exacerbate this issue. Proper allocation of system resources also plays a crucial role. Management can lead to underutilization or overloading of critical component, impending overall system performance. By systematically identifying and addressing these bottlenecks through targeted optimization, strategies, organization and user alike can achieve more robust, efficient, and responsive computing environment. That is all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is FARIZ bin ZAHARI, and now we'll move on to the optimization strategies to improve overall system performance. So, in context of operating system, means that we are using the various methods to make a computer operating system works faster and more efficiently. So in this aspect of optimization technique, for task scheduling, we have here is round robin scheduling and priority scheduling. Basically, these are the two techniques for managing how tasks schedule to use the CPU in a computer system. We have here is round robin scheduling, where it fairly allocates the CPU time among processes, but it can lead to high context switching overload. And for priority scheduling, it allocates CPU time based on process priority, but sometimes may cause starvation of low priority processes. For memory management, we have here is paging and segmentation. Like for paging, it allows efficient use of memory, but it can also lead to fragmentation. And for the segmentation here, provides logical separation of memory, but can be complex to manage. And then for the third one is this optimization. In this optimization, we have here is defragmentation and caching. For defragmentation, it reduces file fragmentation and also improving the disk access time. And for the caching method, the operating system use faster storage, for example SSD, to cache frequently accessed data and speeding up read or write operation. And then for the CPU optimization, for load balancing, where it distribute the workload evenly across multiple CPUs or cores. And for efficient scheduling, we use advanced scheduling algorithm. Like before, we have round robin or priority scheduling. It is just to optimize the CPU time allocation.
Now, my name is YAZID HAKIM. Will present about comparative analysis. So, firstly, we will compare for round robin versus priority scheduling. So, for round robin, it is simple but less efficient for high priority tasks. And while for priority scheduling, is more efficient but can cause low priority starvation. And then paging versus segmentation. For paging, it is more straightforward and widely used, while for segmentation, it can provide better logical organization. Next, this is the example situation, which is we will consider a web server running on a Linux-based operating system have experienced slow response times. So analysis reveal high CPU usage and input-output wait time as the primary bottlenecks. Now we will go to impact of resource management techniques. Okay, first is memory management techniques. It has paging and segmentation. For paging, first, it eliminates external fragmentation. Second, internal fragmentation and large space tables. And it used in modern OS like Windows, Linux. And then for segmentation, firstly, logical separation, which is code data stack. Second, reduce internal fragmentation. Third, external fragmentation and complex management. And it used in older OS such as early Unix. And then second is virtual memory. It have the advantage and also the disadvantage. So we will go to for advantage first. And the advantage is firstly executes larger programs. Second, isolates and protects process. And lastly, improve multitasking. And for the disadvantage, first, tracing from frequent page sweeping. Second, it increase complexity. So, for example, virtual memory used on modern OS like Windows, Linux, and macOS.
Okay, Bismillahirrahmanirrahim. So, Assalamualaikum. My name is Muhammad bin SAMSUDIN, and I will take over to present to you about the CPU scheduling techniques. So, for your information, CPU scheduling techniques have three scheduling: round robin scheduling, priority scheduling, and multi-level queue scheduling. So, for the first scheduling, which is round robin, so the impact on performance for the round robin scheduling is to ensure fair CPU time allocation among processes, preventing starvation. And the negative side is time content size is crucial. Too large can lead to poor response times. Too small can lead to high content switching ahead. So for example, in a time-sharing system, round-robin scheduling ensures that all user processes receive equal CPU time, improving system responsiveness for interactive users. However, if the time quantum is set too short, the system may spend more time performing complex switches than executing processes. And for the next scheduling, which is priority scheduling, so for the positive side, ensures that high priority tasks are executed first, which is important for real-time applications. And for the negative side, low priority process can suffer from starvation if not managed properly. So for the example, it used in a real-time system, which is in a real-time operating system controlling industrial machinery. Priority scheduling ensures that critical control processes receive CPU time before less critical logging or maintenance tasks, maintaining system reliability and performance. And for the next scheduling, which is a multi-level queue scheduling, for the positive side, it separates processes based on priority or type, allowing specialized handling and improving overall efficiency. So for the negative side, it can lead to complexity in managing multiple queues and the movement of processes between queues. For example, an operating system might use multi-level queue scheduling to handle foreground interactive processes with high priority and background batch processes with lower priority. This ensures that interactive applications remain responsive while efficiently processing background tasks. Next, I will explain to you about these management techniques. So for these management techniques, we have two: file system organization and these scheduling algorithms. So for the file system organization, so for the positive side, it is very efficient organization of the file system can significantly reduce file access times and improve system performance. For the negative side, poorly designed file system can lead to fragmentation and slow access times. For example, the NTFS file system used by Windows provides efficient file indexing and supports large volumes, improving performance for systems with large datasets. In contrast, FAT32, an older file system, can suffer from fragmentation and slower access times with large files. So for these scheduling algorithms, it has FCFS, SSDF, and SCAN. So FCFS, it is very simple and fair, and it hide seed times. For the SSDF, it can minimize seed time, and it has a risk of starvation. And for the SCAN, it has a balanced seed time and fairness, and can delay near ends of the disk. Next, trade-offs. So for the trade-offs, paging versus segmentation. So I will explain to you the benefits and the drawbacks for the paging first. So benefits of the paging can eliminate external fragmentation, simplifies memory allocation and reallocation. And for the drawbacks, it can lead to internal fragmentation. So it has wasted space within pages, and page tables can become large and complex. For example, modern operating systems like Windows and Linux use paging to manage memory, allowing processors to use non-contiguous memory spaces efficiently. So for the segmentation, the benefit is it can provide logical expression of program components. For example, code, data, stack, and it can support variable size memory segments, reducing internal fragmentation. So for the drawbacks, it can suffer from external fragmentation. Segment tables can become large and managing segments can be complex. For example, some older operating systems and early versions of Unix use segmentation for memory management. So for the trade-off, then paging provides simplicity and efficient memory use, but can suffer from internal fragmentation and large page tables. Segmentation offers logical program separation and variable segment size, but can lead to external fragmentation and complex segment management. Next, we go to the CPU scheduling, round robin versus priority scheduling. Round robin scheduling provides fairness and simplicity, but may suffer from high context switching overhead. But for the priority scheduling, it can ensure critical tasks receive CPU time, but can cause starvation for lower priority processes. Next, we go to the trade-offs for this management. So, firstly, I will explain to you about file system organization. Efficient file system organization improves performance and data management, but requires careful design to avoid fragmentation and access issues. So for these scheduling algorithms, for the trade-off, FCFS offers simplicity and fairness, but may lead to poor performance. As SDF minimize seek time but can cause starvation. Scan balance seek time and fairness but may introduce delays for some requests. So next, for the summary, each technique offers specific benefits and drawbacks. Choice depends on system requirements and constraints. Balancing simplicity, efficiency, fairness, and complexity is very crucial for this part. So I think that's all for me, and thank you for watching.